So now that we've taken a detailed look at the custom shader that we're going to be creating for our crowd, let us go ahead and kick off the construction of the shader by first making our random color VOP asset. So we've pulled that particular whiteboard slide up right now as a quick reminder as to what we're going to be creating. Remember, we're going to put down 5 constant nodes. These constant nodes are going to be of type color, and this is where our artist will be able to set the range of colors that can possibly come out of this guy. We're going to wire all that into a switch, and the switch index will be driven by this portion of the network up here, where we'll be using a random at its heart to generate a random number that will in the end be a value between 0 and 4. So with that, Steve, let me turn it over to you. Let's put this thing together.
Awesome. So let's jump over to Houdini, jump inside our bleachers asset, and down inside our bleachers shop network. Now I'm going to create the material and the shader that's going to be assigned to all of our audience. It's kind of like our overall shader, and then I'm going to use that as also a place for constructing our 2 smaller assets.
Okay.
And in this video, as mentioned, we're going to be constructing the first of those 2 smaller assets. So let's create a material, and I'm going to push enter to select that, enter to drop that in, and rename this to m_audience. I'm going to jump inside by pushing enter and create a VOP Vex surface shop.
So basically inside the material container at the moment.
Yep.
And here comes our shader container.
And I'm going to wire that to the output of the material.
And now let's jump inside the shader container.
And now we're working in Vex. So let's start out by creating those 5 color constants that we're going to use to drive our random selection. So let's create a constant. I'm going to name this first constant color1. It's going to be of color type with a constant name of color1 and a constant label of color1. I'm going to jump over to the color tab and just pick something like red for the first color. I'm going to duplicate this guy to give us our colors 1 through 5 by Control-C, Control-V, and each time I duplicate this I'm going to update the name, label, and also give it a new color. So color 2, and let's just grab the orange, Control V, color 3, and something like green, Control V, color 4, let's grab blue, and Control V for our 5th color. I'll grab something like that purple that's kind of bright. So that's
kind of bright.
Darken
and
that
you just
down.
went with the lime green?
I like lime green. Okay, lime green's awesome. So
it's glowing though, Steve.
I like lime green.
Okay, so there's our 5 default colors.
Sweet. And we're going to wire these into a switch. So let's drop down a switch. And you can see the switch is complaining because we currently don't have any inputs. You also notice it doesn't know what data type the input is or what the result's going to be. As soon as we wire our first color into input 1, the data type updates to reflect the data type we've chosen to wire in, and the output is obviously going to be of the same data type. So that's wiring color 2 to input 2, 3 to 3, 4 to 4, and 5 into input 5. Now we need to drive our switcher index, and as shown on the whiteboard we're going to be driving this with a random at the heart of that switch index. So let's drop a random VOP into our network. And the random VOP has a huge choice of various input numbers and outputs. We're going to be dealing with a 3D vector input because we want to take our unique ID for each audience member, a global seed, and a local seed in, but we only need a single output. So we're going to select 3D vector input, 1D output. And we can take our vector input and we can wire a float to vect into this so we can deal with each of the components separately. So I'm going to create a float to vec, wire the vector output into the input of our random, and now we can deal with each of our individual float components on their own. So for the first one, we wanted to bring in our sphere ID, and that's going to be a unique ID for each of our audience members. Now we have a unique ID for each of these guys. We have a point number of the point they're being copied to. So what we can do, we can create a parameter down inside our shader that will listen out for a particular parameter name, and then up at SOP level we can associate that parameter name with the point number that we're copying our audience member to. So let's create the parameter first. So I'm going to drop down a parameter VOP, and let's rename this to something like sphere ID import. We're dealing with an integer type since we're dealing with point numbers. The parameter name is going to be sphere ID. And this is very important that the spelling we use here is what we use when we're referring to it back up at the SOP level, so sphere ID. And the parameter label, sphere ID. Now I'm going to check invisible because currently if we were to jump up to look at our VopVex surface shot, we can see sphere ID as something we could set up here, and we know that we're going to be passing this down from the SOP level, so we don't need to set it here. By checking invisible, that just hides it out when we're selecting this node. So we've got our parameter in place. Now I'm going to jump up until we're in SOP level and deal with first assigning this shader to our audience, and then with passing down the information we need for this parameter. So I'm going to jump up until we're at SOP level by pushing the U key. And here where we're dealing with our audience sphere, I'm going to wire directly out of the audience sphere into a material SOP. So I'm going to right click on the output and wire this into a material SOP. And let's rename this to something like audience material. And we can browse for our material and grab our m_audience from inside our bleachers shop network, making sure to export a relative path. Now, we can also specify a local override. What a local override will allow us to do is specify a parameter name, the data type of that parameter, and then the value that we wish to pass in for that parameter. If we were to pass in a stamped value, every time we copy an audience member, we're going to pass a different value down into our shader, so each audience member will get shaded using a different value on that parameter. So let's add a local override by clicking on the plus button. And the parameter name we're dealing with, we know is sphere ID. And we need to make sure we spell this in the exact same way as when we were creating that parameter down inside the network. We're also going to make sure that this is an integer value, since sphere ID, when we created it down inside our shader, was an integer, and since we're dealing with point numbers, that is also an integer. And the integer value, we can now use a stamp expression to grab the point number that the current audience member is being copied to. So let's use a stamp expression. And we're going to be grabbing from our copy audience. And if you recall, I'll jump back there in a second to just double check, but if you recall, we had a parameter that we stamped which was called sphere_num, which contained our point number, defaulting that stamp expression to 0 there. So if we jump back to our copy audience, sphere_num, it's a stamp parameter on copy audience containing $PT. So what we're doing for every audience member we copy, we're stamping the point number back up to the material and passing that point number down as the sphere ID, such that when we're inside our shader, jumping down now inside our shop network, inside our material, inside our shader, for every single audience member being shaded, sphere ID coming in here will be the point number for that audience member. Now we want to wire this into the first input into our random, but you can notice this is an integer, this is a float, so we need to convert it first. So I'm going to right click on the output of sphere ID and wire this into an integer to float up there, enter to accept that, enter to drop this into the network, and then we can take the float value and wire that into fval1. I'm also going to grab our parameter vop and move it out to the side, since our parameter vop is going to be global to our entire shader. Everything we're creating over here is going to be local to the asset that we're building in this video. So that's our first of 3 inputs. Our second and third inputs need to be our global and local seed. So let's create our global seed. And what I'm going to use for that is a constant vop. Let's create a constant vop. Let's move him over here with our sphere ID, since our global seed is global to the entire shader. And I'll rename this to global seed. I'm going to choose to use an integer, and that's just a personal preference in this case. I like having seed values when we're dealing with our shader. It's nice to have all of our seed values as integer. I just personally feel it looks cleaner than having floating point values. You could use a float. If you set this guy to float, everything would still work, but I'm just personally going with integers. I'm going to give it a constant name of global seed and a constant label of global seed. Now you see on the constant vop we have the ability to specify an integer default. Now what if we were to go up to our asset, create an integer parameter, and then reference that parameter here? What would happen is whatever the parameter was set to on our asset, when this shader is invoked, that value would be used for our integer default for this constant, and so that value would be fed throughout the rest of this network wherever global seed is wired into. So let's jump up to our asset now and create that integer parameter for our global seed, and then we can jump back down inside and reference that for the integer default on our global seed constant fop. So I'm going to jump up until we see our asset. I'm going to right click on our bleachers asset and come down to type properties, that is off the bottom of the capture region there. And on the parameters tab, I'm going to come down and find our audience folder. I'm going to create a new folder for our shader. So let's drop in a new folder inside our audience, and I'm going to rename this to crowd shader. And inside our crowd shader folder, I'm going to create an integer parameter, which is going to be our global seed. So global seed. I'm just going to give this the label of seed, and I'm going to give it a range of 0 through to 1,000, just so we have a really large range on our slider. And if I accept this and then bring up the parameters for our asset, you'll see underneath our audience folder, next to our animation folder, we now have our global seed parameter. So we need to jump back inside our shader and reference this parameter on our constant fop. So I'm going to close this out, jump down inside our shot network, inside our material, inside our shader, and here on the global seed fop, I'm going to set integer default to be our parameter, which is up. So that's going to take us outside of our VOP network. It's going to take us outside of the material. This is going to take us outside of our shot network. This is going to take us up to our asset, and then we can grab our overall seed.
Now the neat thing to
which
remember,
I called global seed.
Yeah.
There we go.
The neat thing to remember is that this expression is being created on this parameter down at the template level. Remember, we're still defining a template for our digital asset, so we'll be instantiating this asset as we, make instances of it in our shader network.
Well, actually, this particular parameter is our global, but we are about to do that with our local.
We're about to do that one. Oh, that's what I get for looking at just seed.
Yeah, but yeah, this is our global one, but it's going to work in a very similar way with our local.
So what I just said a second ago, hold that for just a second.
Just about to apply.
We're going to do it in about 2 seconds.
Yeah, so we're just going to wire this guy into an int float, and then we're going to do it. Yeah. You're just so excited to get onto the next bit.
No, it is neat. It's just the idea of actually referencing back up, and then we're going to package that up, so no matter how many times we instantiate this, basically how many times we use it, it's always going to be looking back up automatically.
Mm-hmm. Cool. So I'm going to grab our integer to float that we already had in our history, so we can convert this guy to a float. I'm just going to move this over here because these int to float conversions are also going to be part of that asset that we create. So all we have to worry about is wiring in our sphere ID and our global seed, and not about converting them beforehand. I'm going to take that floating point value and wire that into fval2. So now let's create the constant for our local seed. So constant. And this is going to be, I'm going to create another integer since we're dealing with a seed. Name this guy local seed. Give it a name, lead, local seed. And a constant label of local seed.
And this is the seed node that will be
exactly,
wrapped up.
Because we're going to wrap it
asset.
up. We're going to give the asset a parameter that controls this, and every time we drop in a new instance of the asset, if we just change that parameter on the asset, we'll automatically change this guy. More interestingly, every time we drop in an instance of that asset, we're going to promote up the asset's parameters up to our master asset. So then we have control of each of these local seeds up on our shader, so we can change the seed for our shirt, so we can change the seed for our hair, etc., etc.
Exactly.
Fantastic. So this is our local seed, and again, we're going to convert it from an int to a float. So integer to float, enter and enter. And wire this into fval3. Now when we create our mini asset, I'm going to then link up our integer default to a parameter on that asset. So we've got our random being generated, and we know this is coming out with a value of 0 to 1, and as we saw over on the whiteboard, we want to multiply that value with our number of colors parameter. So I'm going to create a new constant. I'm just going to shift this up slightly. Drop in a new constant. This is going to be an integer constant for our number of colors. So I'm going to name this num colors. It's going to be an integer with a constant name of num colors and a constant label of num. Wow. That's really messing up my spelling there. Num colors, fantastic. And again, we've got an integer default that when we create our asset for our color switcher, we can promote this up to our asset and also have that 1 through 5 control of how many of these colors do we want to use. So we can take the output of our random, multiply it by num colors, and then we're going to be able to convert that float value over to an int and use it to generate our switch input. So let's right click on the output of the random and wire this into a multiply VOP. Take the output of num colors also into our multiply VOP. As you can see here, we multiply the two together. We're now going to convert over to an integer. So float to integer, which again is going to truncate that value. And we can take the truncated value, there we go, move him over, and wire that into our switcher index. Fantastic. So now, based on the sphere ID, the global seed and the local seed, we're going to generate a random number, multiply that random number by however many color swatches we want to use. That's going to then give us our switch index and switch between those colors. The output is going to be our color, so we're now ready to wrap this all up as an asset. Now before we do this, to make life just a little bit easier, I'm going to wire the result to our color for the shaders output. The reason for this is if we have a wire coming out of a node when we collapse it down into a subnet, we'll automatically have that output being wired into the outputs for the subnet, in the same way that because we have sphere ID and global seed already coming into the nodes we're going to collapse into a subnet, we'll automatically have our subnet with those inputs that we need. That's going to make life nice and easy. So I'm going to grab everybody except for our sphere ID, our global seed, and the output for our shader. So that's all of our colors, all of the switch, and the random number generation for the switch. I'm going to push Shift-C to collapse this down into a subnet. And with this subnet, you can see that we've got our two inputs that we said we were going to have, sphere ID and our global seed, and the output result is going to be our color. Now, if we jump down inside our subnet and find the sub output node, which we can see we've just got our color result wired into, if we select this node, we can rename this particular parameter, and that allows us to have the result being named as color as opposed to just result, so that when we create the asset, we'll see that we take in our sphere ID and our global seed and the output is color. It's more meaningful than just having the output being result. So I'm going to click in the name field and name this oops, let's make sure we're actually in the name field when we're typing. Name this color, and I'm going to give the label as color with a capital C. So we can now see that this guy's named color, and when we jump up, we now have color coming out the output of our subnet. And we can right click on our subnet and create a digital asset. Before we do that, it'd probably be a good idea to rename him. And I'm going to rename him to, I guess, random color would be following what we've used on the whiteboard. So let's rename him to random color. And I'm going to right click and come down to create digital asset with the asset name of random color, the operator label of random color, and I'm going to create a new OTL that's going to contain both our random color and random texture VOP assets. So I'm going to bring this up, I'm going to find our OTLs folder within our project, and what do you think we should call this guy? Something like shaders.otl?
That'll work.
Or shaderutilities.otl?
Either way.
We'll just call this shaders.otl for now. Feel free to name this
Sure.
whatever you'd like. So shaders.otl and accept. I'm only going to install this to our HIP file. So if we accept that, we'll get the type properties come up. We've automatically got the sphere ID and global seed inputs that we needed, but we also wanted to promote up things like our number of maps, that local seed, and most importantly, the 5 colors that we want to set that are going to be the 5 colors we switch between. So let's promote up first our number of maps and our local seed. So what I'm going to do, I'm going to just shrink this down, and with it still open but over here on the side, I'm going to jump down into our network, find the parameters we want to promote, and promote them up to our asset. I'm also going to make sure that prefix linked name and label are unchecked. So let's jump down inside our asset, and let's hunt down first our number of colors. So I'm going to find number of colors, and if you remember, we said integer default was going to be the parameter that controls the value coming out of here, so let's promote that up to our asset. So I'm going to right click on integer default, export parameter to type properties. We've got that integer, so I'm going to give this a name of num colors and a label of num colors, and we do want to lock this between a range of 1 and 5, since we always want to have at least one color, and we don't want to go beyond 5 because we only have 5 color constants being wired into the switch. I'm now going to come over and hunt down our local seed and do the same. So I'm going to right click, export parameter to type properties. Let's name this guy to local seed. Give this just the value of seed, and the reason for this is we saw when we were designing how we wanted our attributes to be laid out, our parameters to be laid out. For the overall asset, we didn't have local seed as a name when we were dealing down in the folder. We just had inside the folder another seed parameter. So I'm just going to name this guy to seed. And I'll give him an unlocked range of 0 to 1000, so we have a nice range of control on our slider. So all that's left to promote now are our 5 colors. I am going to move this input node so things aren't quite as cluttered. So let's grab color 1 and export, color 2, export, color 3, export, color 4, export, and color 5, export. I'm going to go back through and rename. So our label currently is color default. I'm going to name this to color 1, color 2, color 3, color 4, and color 5. I'm also going to move the seed so that it sits beneath the colors, just because that to me makes more sense. Now we could call it there and everything would function correctly for this asset. However, it would be nice if when we say we're only going to use one color, we only have color 1 active. When we say we want to use 2 colors, we only have 1 and 2 active. And this is really easy to do. We're going to specify disable whens for every color except for color 1, since color 1's always active. And we're going to reference our num colors parameter. So for color 2, we're going to disable when num colors is less than 2. Because if num colors is less than 2, then we don't have 2 colors, thus color 2 doesn't need to be active. I'm going to copy this, and for color 3, we're going to be disabled when num colors is less than 3. For color 4, we'll disable when it's less than 4, and for color 5, we'll disable when it's less than 5. So if we accept this, and then jump up, we can see for this particular instance of our random color asset, we have the ability to specify how many colors do we want. 1, 2, 3, 4, and 5. They'll be enabled and disabled, remembering also that this is directly controlling, if we jump inside our asset, our integer value that's being multiplied with our random, so it's also controlling the range of colors that are allowed to come out of this switch. So let's say, for example, we're going to allow all 5 colors. You'll see that our switch output is being wired out of our random color, and that our color output currently is driving the color. So we'll end up with just constant shading, but we should see a variety of colors across our audience if we were to render now. So let's just do a quick test render. Fantastic, and you can see that we've got red all the way through to purple being selected. Now let's say we were to change our seed and re-render. If we flip between these, we can see those colors are changing, and this as our local seed, local to our color asset. Now I am in a minute going to jump up to our global seed and change that too, but while we're here, let's deal with changing this number of colors so we can show what if we only want red and orange spheres to be created. Let's re-render, and we can see we only have red and orange spheres. Let's say everything except for purple spheres being created, and re-render. Fantastic. So I'm going to set this back up to 5. I'm going to jump up to our overall asset, bring up the parameters for that asset. Let's just grab those parameters over to the side. And let's change our overall seed and render. And then change our seed again and re-render, and we should see a shift. If that takes, there we go. Let's re-render. There we go. So, and when we change our overall seed, everyone is shifting. So we've now got a very quick and easy way, if I just close this out, jump back down inside our shader, an easy way to come in and say, okay, I want a way of switching between 5 random colors, drop in our random color, make sure that we wire up our sphere ID and global seed from over here, and then we can simply take that output and we don't have to worry about all of those nodes inside and how they're working. We can just drop in the instance of that asset.
Excellent. Okay, so with that, that's going to wrap up everything from this video. Thanks.